Hi, everybody. So today we are going to extend our discussions on projectile motion. And in our last video, we had gone through the basics of projectile motion and got the equations related to the range of the projectile, which is this OP. We see this equation here, and then also the time of flight, the time it takes for projectile to go up and eventually lands to ground, and also the maximum height. So these kind of derivations we had done in our last video. So today we are going to understand at what angle of projection this theta, the maximum range of the projectile, can be achieved. So we have this expression, which is the range is u square sine 2 theta by g. In this u square by g can be considered as constant, and sine 2 theta is something which we need to maximize to find the maximum OP. So what's the maximum value sine 2 theta can reach? That is 1. 1 is the maximum value. At what angle of projection, at what 2 theta, this value would be 1. Sine 2 theta would be 1. We know that sine 90 is 1. Hence, the theta should be, 2 theta should be 90 degree. Hence, we have theta as 45 degrees. What does it mean? At 45 degrees of angle of projection, the projectile reaches to the maximum range. The projectile achieves the maximum range. Okay. And what would be that maximum range? Maximum range would be u square by g. It would be meters. Okay. So this would be the maximum range. All right. So now we are going to derive the equation for this curve, projectile motion curve, or essentially we are going to get the trajectory in xy plane. So from our previous session, we got to know about these expressions: x is u cos theta t and y is u sine theta t minus half gt square. So considering this as equation 1 and this as 2, and how did we get it? In my previous session, I talked about this: y is equals to u sine theta t minus half gt square, and then the x component was u cos theta multiplied by t. Okay, so now we will eliminate t from our equation. So what t becomes from equation 1, x divided by u cos theta. We will put this value in equation 2. So y would become u sine theta multiplied by x by u cos theta minus half g t square, x by u cos theta square. Right, so from this equation, we get y is equal to u tan theta. And since I have kept u, okay, so u can be eliminated from here. So essentially it becomes x, and we will erase this because u got removed, minus half g u square cos square theta multiplied by x square. So right, let's assume a as minus half g u square cos square theta, which can be written as minus g by 2 u square cos square theta, and then b can be written as, from this one, tan theta. Hmm? So placing both of these to this equation, y can be written as uh, bx minus ax square. So this is the equation. Very important equation. So we are naming it as 3. So what is this equation? This is essentially the relationship in between y and the x-axis for the projectile motion, and this is the equation for typical parabola. So what is the shape of this trajectory? This is parabolic shape, right? So this is parabola, and if we see, the coefficient of x is negative, minus a is less than 0, hence the parabola has a shape upside down with respect to the coordinate system. And since it has a b, then therefore we have a shift from origin to some point, right? So at this position, this is y-axis and x-axis. From your mathematics classes, you can get the slope dy by dx that would be equal to 0. So we can differentiate the equation 3. It becomes 0 b minus 2ax, hence the x would be b by 2a. So this point is b by 2a. Let's calculate OP, this point, this point. At these 2 points, y is equal to 0. So we can put in this equation, 0 is equal to bx minus ax square. Hence we get two solutions, 0 and b by a. So at these two positions, which is this and this, our y is equal to 0 and b by a is the range. So range of projectile is b by a, and we can see at the midway on x-axis, the projectile reaches the maximum point, right? And we can also derive the height h from this. What would be h? If we place this value in this equation, we can get what is the value of h. So y at y equal to h, bx, what is x? B multiplied by b by 2a minus ax square. What is a? A is this, and what is x? B by 2a. So I can write x is equals to b by 2a square. So hence h would be b square by 2a, and it becomes ab square by 4 a square. So this goes away, and then we have b square by 4a is h. Right. So essentially, what I'm trying to tell here, don't memorize these things. These all things got derived from basics, right? And we have used the very basic of fundamental principles over here, right? And we can derive all such things. So these things will help you to solve the complex problems as well, right? So you can have problems like there is a projectile which was thrown from point O, and there is some kind of higher point. On this, it lands at point P1. And if this height is given, say h1, you need to calculate the time of flight and so on. So all these things can be done if you go with basics. Don't memorize any formulas. And I'm trying to focus more on concepts, not on tricks here. Yeah. So with this, I think we have finished the projectile motion related aspects. In our next session, we would be talking about and trying to solve some of the questions related to projectile motion.